Hey guys, Clem here. Now let's move on to SQL databases. In the previous video, we talked about NoSQL databases like MongoDB, which is the non-structured type of databases. In this video, we're going to be covering integrating our Node.js server with an SQL database, which is a structured database. If you want to know more about the meaning definitions of databases, you can check the previous video in this course. But we're going to move ahead now and learn how to integrate Node.js and SQL databases. So basically, just a TLDR what SQL databases are. They are structured databases, and SQL stands for Structured Query Language, which is a language in and of itself that is used to interact, query, and edit the structured database. And you can imagine this database to look like an Excel sheet if you've ever worked with Microsoft Excel, like a table that has columns and rows and how we can interact and insert data and delete and update, data on the database. Essentially, in this video, we're going to be covering how to perform the C.r.u.d operations on SQL databases as well. Because in the previous video, we talked about the C.r.u.d operations on NoSQL databases. So I'm going to show you guys how to do that now. So let's move on. In the previous video, we used MongoDB Atlas as our database server that we were interacting with our Node.js system. In this video, we're going to be using something different. And I found out that there are a lot of services online that have SQL databases integrated in them. You can also install an SQL database on your computer system, but I'm thinking of a way to make it so that we can easily integrate this in your production app. So I found it easy to just make use of an external system, not just your computer system, if that makes sense. Anyways, let's move on ahead and talk about what we're going to be using for our own SQL system, which is ScaleGrid.io. So you can go ahead and navigate to console.scalegrid.io, create an account, and it's a pretty simple, straightforward process. The same process you'd expect for any service online, really. So create an account and then it will take you to the dashboard. And when you do that, you can pause and do that and then get back to this part, the next part of the video. And if you've done that, you'll be taken to the dashboard, which of course you can go to the left panel here and you can easily select the SQL database. And this says MySQL. MySQL is sort of like an integrating language with SQL in itself. And we're going to be using the MySQL package in Node.js, which I'll show you guys shortly how we can integrate. But before we do all that, let us try to actually create a cluster of the SQL database, the same way we did in the previous video for the NoSQL MongoDB Atlas database. How you do that is you click on New MySQL deployment. As you can see here, I already have a SQL deployment that I did a few hours ago with some testing. But to do your own new deployment, you can just click on the new MySQL deployment and you can follow the prompt. You can call this whatever you want. You can call this my first SQL deployment. And you can just select dedicated hosting. And then I usually select AWS here. And that is literally all you need to do, and click on next. Oh, and be careful of this. There are no special characters allowed. So just use hyphens instead of this underscore. So make sure it's a hyphen and bad. So make sure you use hyphens and not underscores. For some reason, it doesn't accept underscores. So click on next. And for location, you can choose the location, the server location that is closest to you. This is really important if you're building a system for a particular group of people and you want to be able to select the server that's closest to you. In my own case, it is going to be London. And I click on next. And then I'll just leave the default systems here for now, but you can choose to enable SSL if you want to. I'm just going to leave the default for now since this is a test database. And for the firewall, make sure to add your own IP address to this, or you won't be able to connect to it with your Node.js system. You can only connect to the database if you whitelist your own IP address. So has already happened here. So I'm going to click on next, and it's just telling you to review every single thing, and it all looks good. It already automatically added my IP address, so I don't need to add it manually again. Although if you want to add a second IP address, I can show you how to do that after the deployment gets created. When I click on create, as you can see here, I already have one dedicated database here. So that is why it's telling me I can create another one. And this is a trial plan, but obviously it will go ahead and create that database in your own case. And it usually takes about 20-30 minutes to be fully deployed. For some reason, it's kind of slow. But after it's done, you'll be able to interact with the database and make everything work perfectly. So wait that 20 minutes and then let's get back to the video. When the deployment has finished, you will be able to enter into your cluster here. And when you go in, you'll see the status here of running, showing that the cluster is actually fully deployed. Awesome. And you can then use your username and password and do what you will with it. You can reveal it here just so you can put it in your system. And of course, you can also do certain things. I suggest the first thing you do is you go here and create a database, or you can go to users and you can also create a new user if you want to, but there's already a default user you can connect with. But the first step I will do is to go to databases and make a new database. I can make me just call this database with the name of your application, for example, like my pizzeria or whatever you want to do, or store in this database pretty much. So I'm creating a database called My Pizzeria. Awesome. I have a new database called My Pizzeria. Sounds good. So how do I connect to this database now? How do I, work with it? I can head on over to overview again, and I can just check on the different details that I can use to connect to my cluster. And I can also try to use the configure more firewall rules by clicking on firewall rules, and I can add IP addresses here in case you want to add more IP addresses to this particular cluster that you've created. Or you want to delete any IP address here to just limit the level of connectivity people can have to your cluster. Awesome. So the first step I want to do is I want to copy a couple of things here. I'm going to copy this master link here for later. And let's start with the code for Node.js to integrate with this database that we have just created. Going back to our server.js file here, we want to start connecting to this database. How do we do that? We need to install a node package called MySQL, which is in the node package manager. And how do we do that? And before we even do that, we need to initialize. Since we are going to be using a third-party package, we need to initialize our node package manager in package.json. To do that, I will say npm, as you notice already, init, and to just answer all of the queries they're going to ask us, I'll just use a -y and press enter. And I can see that my package.json has been created. Awesome. So the next step, of course, is to bring in MySQL, but I have to install it first before I bring it in. That's true. So I'll just say npm install MySQL. Awesome. It's installed. So we can then try to bring it in by saying const MySQL is equal to require MySQL. Simple. So how do we then connect to our database after installing MySQL? The first step is to create a connection to the database, a connection variable. And I'll call this connection variable, you guessed it, connection. And connection is equal to MySQL.createConnection. And create connection is a method of the MySQL package here. And it takes in an object as an argument. And this object is an object of options. And the first option, of course, is the host. And what is the host? I'll have to copy this URL here. Just copying this URL on the connection endpoint. And I'll paste it here. And when I paste it, the next step, of course, is to type in the user or the username. And how do I get that? I click on show under credentials here, click on show. And once I click on show, I see I get the username and the password that was auto-generated for me when I created this cluster. So the username is sg.root. I'm going to copy this, paste it in here. And of course, I need to type in the password. The password is, of course, this long string here. Paste it. Awesome. And of course, I want to type in the database. Remember, we created a database. If I can remember the name, I forget the name now. I think, let me just go under databases. And I think I called the database My Pizzeria, right? So I'm just going to copy the new database I created here and call it My Pizzeria. And I'm going to then type in the port connection, which I believe, if I go here, looking at everything, and how you see the port connection is under this connection string. You can click on see more, and you can see that. In fact, even under this thing, you can see that they all use a port of 3306 here. So the port we're going to use as a default is, of course, 3306. So this is just the instructions for this particular SQL connection. The port may be different for other systems, but for this particular database, for this particular cluster, you need to take note of what the port is, which you can easily see here under the strings. So it's very, very visible here. And even in the command line syntax here, you can see 3306 is the port as well. So the port is 3306. The next step, of course, is to connect with the connection. So I say connection dot connect. And this connect takes in a argument, callback function, which if there's an error, we would like to throw an error, which means we want to throw that an error actually has occurred and end the process. Else, or no need for else because it's going to end the process. You know, if the process doesn't end, we're going to console.log that we are connected to MySQL. Awesome. So let's save this real quick and let's see whether we can get this connection to MySQL. I'm going to the console now. I'm going to clear the console first by typing clear. And I'm going to say node server. Awesome. And I get connected to MySQL because I typed in the host, the user, the password, and the database. And because I created the database, it was able to find it. What happens if I use a wrong database? And this is one funny part of this package. If I use a wrong database, if I just, editing the database name to something that does not exist, and I try to connect, I get error, bad DB error, unknown database, this random string. So it's very important to make a database first when using ScaleGrid.io before we actually start connecting to the database, if that makes sense. So now we have successfully connected to our database, our SQL database, so we can start performing the C.r.u.d operations, which is C.r.u.d is C.r.u.d. of course, and it stands for create, read, update, and delete. So how do we create data in our database? How do we read data? How do we update? And how do we delete data? This works a little bit differently from NoSQL or MongoDB because to actually create data, well, not too different, but it has its own differences. In NoSQL, we needed to make a schema and then a model. But in SQL, we would need to create a table first. A table generally is just a means of storing some data. Like if I want to have a group of users in my application, I'll create a table of users to store them. If I want to have a list of transactions in my application, I'll create a table of transactions to store that data. And that table will have certain columns which represent certain columns which represents the type of data being stored there. If it's the ID, if it's the name, whatever you want to store. And I'll show you this very quickly. So before we perform any CRUD operation, we need to create a table, right? And we're going to have in your application, you're going to have multiple, in a real application, you're going to have multiple tables to create. Again, this is not an SQL course, so I'm going to go in as in-depth as I believe is possible, but there's much more to SQL that I'm going to cover, but I'm covering the basics, the very important basics for you to expand your knowledge in SQL. So how do I create a table? So how SQL works is it's a query language, it's a structured query language. So we're going to be writing some preliminary SQL here. And how do we do that? We say const create table query, and we want to create a table called users. I'm going to make this into a string, a backtick string, and I'm going to write on a new line in between the string by pressing enter a couple of times so that I can write a couple of strings here, which is going to be essentially some SQL language here. And to create that table of users, I'll say create a table called users. Right? This is the first three words, create table, name of table, and create table should be in all caps. And when I do that, I'm going to have an object here. Not an object, excuse me, a bracket here rather, and parentheses, as you can also call it. Press enter. And then what are the things I want this, what are the columns I want this user's table to have? I want it to have an ID that is an integer and increases every time that a new item is added to it. So it's generally will start as 1 and then increases to 2 when a second item is added, and 3 and then 4 continuously when new items are added. And I'm going to give it another tag called primary, and I want to give it another tag called key. Essentially, primary just indicates that it's going to be unique for a particular entry in that table, so it's a primary key pretty much. This ID is very important because it's a way to actually detect to actually find a particular entry in the most unique way possible, because we know it's going to be a unique key. We know it's not going to be another record that this ID is going to have. Anyway, that's enough yapper about the ID, but this is very important because it's going to dictate which ID the user is going to have, which is very important. So enough yapper about that. The next column it's going to have is going to be called name, and name is going to be a lot easier. This is something we're going to write here called var_char. And bear with me here because this is some new SQL stuff. So this var_char just means that it's a variable character type, and it's going to have a maximum of 255 characters. So that's what this means. It just means like it just simply means it's a long string with 255 characters, and it is not null, meaning it is required and it can never be null. And if you try to add an entry to this table with a name that is null, it'll tell you, nope, it can't be added. It'll throw an error. So if you want it to be required, set it at not null. Awesome. And the next step, of course, is let's add another column called age, which is going to be an integer that is not null. Then the final step is an email, which is going to be a var_char, which means it's a long string, but the maximum is 255 characters long, which is a convention at this point, and it is not null. Awesome. So now this is the complete SQL query. I know this looks different. It's not nodejs that is being used in this query table string. This is actually pure SQL right here. And we will then use nodejs to execute this structured query language. So this is the query here. So how do we execute this query is the question. Very easy. We'll say connection, which is the actual connection that we created here at the top in line 8. Connection.query, which then takes in the create table query, which is a query to create a table before we can start adding new data to that table. And then the next argument of this method, the first argument in the query, the next argument of the method is a callback function of when the query actually is executed. And the first item there is the error. The first argument of that callback function is the error. The second argument is the result. Of course, if there's an error, we would like to throw the error. Right? Or we can just console and log the error, but throwing does the same thing essentially. So, and we will want to terminate the process when there is an error with the query. And if there is no error, we would like to console and log the result and say table created. Awesome. We've written a lot of stuff, and I really do hope it's going to work, because as you can see here, it's not a very, very beautiful language to write all the time, but there may be some mistakes, but I believe this is going to work perfectly, and just following the rules will make everything work easily for you. So you can see we have an ID, a name, an age, and an email. So let's execute this code. So I'm just going to clear as usual by typing clear in my console, and I'm going to say node server. Awesome. What happened here now? Oh, there's a syntax error. I see. I will, of course, have a syntax error because I didn't add comma here. And this is very important. After every line, you need to add a comma to differentiate different lines. This is extremely important and a very common error, apparently. So it helps to separate each query here. So, and I'm going to rename this table as well, because I think I've created this table before for this database. I forget, but I think I have created it before. So I'm just going to call this table, I'll call this app users, but you can call it whatever you want. The name here doesn't really matter. Just call it whatever you want. I'm going to call it app_users. You can choose to follow me as well, so you can have the same thing. So I'm going to call it app users. I'm going to clear this again, and I'm going to try to run the code again. Awesome. So I get table created, which is pretty cool. So I have a brand new table here now. Let's see whether we have that table on ScaleGrid.io now. Sometimes it can be a little delayed in showing these things, but let's check whether we have it there. I'm going to go to databases. You see, I'm in my pizzeria. Let me go back to databases again. So I think if it doesn't reflect, when you go to databases here, you need to actually refresh. So when you refresh, you see the data size did change. Let's go in and click on manage under my pizzeria database. And we can see that, let me see here, row count. It's weird. It doesn't really update so much in real time, but it will update eventually. And I will show you how to retrieve this without needing to go to this dashboard, because sometimes it gets a little delayed in bringing back the actual entries of the database. I think it's here now. I think so. Oh, yeah, sorry, my bad. So basically, obviously there's no row in here. It just created an index. There is no row, clearly, because we haven't added any item in. My bad on that. So obviously there are no rows here yet. So we've not done any CRUD operation. We just created a table. And if we click on tables here, we can see that we have app users. Awesome. So we have app users here. So we have a brand new table to work with. Great. So the next step is to be able to add said app users into the table. So how do we do that? The first step, of course, is let's just comment out this code so we don't keep on trying to create a new table. And what I'm going to do is I'm going to do the create part of the CRUD operation, which involves writing a query to create the user in the app users table. So how do we do that? I'm going to just do this as straightforward as possible. I'll call this const insert user query. I can call it create user query is equal to, and I'm going to use the same method here. I'm going to write backticks, and I'm going to say, I'm going to insert into the app users table by saying insert, not create, insert. And this is me typing SQL code now. Insert into app underscore users. And then I'm going to have my bracket here. And what do I want to insert? I want to insert name, age, and email. And what do I want to insert for name, age, and email? I want to insert values here. And what values are going to be for name, age, and email? Those values are going to be, I'll call this person Clem Brighting. This is his full name. This first argument here goes for the name. Second argument is the age. I'll call this 30. And I'll call this guy's email clembright@gmail.com. So in theory, this should be the complete query. As you can see, the schema here is insert into name of table, the items you want to insert into the table, and the values in all caps comes next. And you're going to have the parentheses here mapped to the initial parentheses at the very top here. Awesome. So how do we execute this query? We say connection dot query is create user query. Just like what we did at the very top here, we're going to say connection to query. The query comes in here, and then the callback function from the query comes here. And then when that is done, we say if there is an error, we throw the error. Else, obviously, if it's successful, we then want to say log out the result, and we want to say user created or inserted, whatever you want to add there. Awesome. So we have our next query, which was this, pretty short, pretty straightforward. So let's try to run the code again and say node server. We get user created, which is pretty cool. Let's see whether or not we get an update on the database. So I'm just going to click on refresh here. Okay, it's refreshed. Let's see whether we can get a new item in the new row here. We can see we have rows here is 1. We have 1 item in the rows. But not yet figured out how to actually see that item here on ScaleGrid. I can't seem to be able to access that item, but you can, of course, retrieve the items created with your code, the SQL code. But there's no UI here to supplement that, which is pretty weird, but it's still very effective. It's still a very good database, ScaleGrid. So now that we have created the user here in ScaleGrid, how do we actually find items in this particular table? How do we read items, which is the R part of the CRUD acronym? So we're going to see how we can actually read an item. So we're just going to comment out the create part. Then we go to read. How do we read an item? We need to make a query and then query. It's that simple. So I'll say const read users query is equal to, it's going to have backticks. And then I'm going to say select, stay with me here, star from app users. This simply means I want to select every single item from the app users table. And then I'm just going to do the same thing here and say connection.query read users query. And then, which is the error, the second argument is the callback function, of course, which takes in the error result. And then essentially just say, if there's an error, we want to throw the error. And else we want to say results users found, pretty much. And then this should be it. This is just the same thing as the previous one, just that we changed the query language here. Change the query syntax here, rather. Let's try to run this now. Node server, users found. You can see that I've gotten all the users, which is just one user, which has an ID of 1, of course, because that auto increases, a name of Clem Brighton, age of 30, and email here. Now, what if I wanted to get just a single user and not an array, as you see here, of multiple users? To do that, I want to actually create another user, and just to make this very clear. So I'm just going to comment out this part of the read, and I'm going to uncomment the create query again. Just for the meantime, stay with me here. So I want to insert a new user, and I'm going to call this user Jacob. And he's going to be age 25, and he's going to have an email of jacob25@gmail.com. Pretty basic stuff. So if I'm going to try to create this new user again called Jacob, I'm just going to quickly run node server. And as you can see here, a new user has been created. Awesome. I'm going to comment out this create part now, because I know that we have 2 users in our database right now. And I want to uncomment out this read part again that gets every single item of the app users table. So let's run this code to see how many users we get out of this. We see that we have 2 users found, which is the first user is Clem Brighton with an ID of 1. The second user is Jacob with an ID of 2, which stresses this auto increment part of the table description we did. So we have 2 users. Let's say we want to only find Jacob, or a user that has an ID of 2. How exactly do we do that? Well, I'm just going to comment this out, and I'm going to create a new item here called read single or read specific item. And to do that, I want to make a new query and say const read specific user query. This is going to be, of course, be a backtick again. And I'm going to say, I want to select a user that has the ID equal to 2. So to do that, I'm just going to say select star from users where, in this case, not users anyways, from app users, because this is the table we're selecting from, where the ID column is equal to, and in this case, I'm just going to write question mark. This is going to make sense in a short while, in a few seconds, when I'm going to write the query. So when I say connection.query, then of course I want to have read specific user query as the first argument, but as a second argument, I'm going to have an array where I type in the user ID that I want to search for, which in this case, of course, is 2. So, or to make it better, I can just have like a user ID variable here. This just says 2 here, so that I can change it easily on the fly at the very top of the file here. I'm just going to call this 2. So it's going to find users that have the user ID here equal to 2. Make sense? So this is going to be the second argument. And the third argument then will now be a callback function that has the error and result and all that fine jazz. And then of course, if there's an error, we want to throw error. And if there is no error, we want to then const.log the result, of course. Say results. Awesome. So let's try to run this code. Hopefully it runs perfectly. We'll see. Awesome. We get the result now. As you can see, we still get an array, of course, but we only get Jacob. Let's say we want to make this to get the name instead of the ID. So you can say the name here, where name equal to question mark. I'm going to say when, in this case, name will be Jacob, right? And this will be user ID to be name. So we're going to get all the users that have a name called Jacob, for example. So let's try to run this code again. We, of course, to get Jacob, but let's see if we can get the first user, which is Clem Brighton, I believe was his name, I forget. Yeah, Clem Brighton. So let's see if we can get that user. Of course, get Clem Brighton. But if the user does not exist, what do we get? Let me just edit the name to be something that clearly doesn't exist in the database. Let me run the code. You can see we get an empty array as the results. I hope that makes sense and how we can get a specific user. The next thing, of course, is the update part of things, which is the U part of the CRUD operations, which are very important in building a full stack backend system. We want to go to update data in the database. So how do we update a data in a table? Let's say the app users table in this instance. It's going to be the same jazz. We're going to have a query here that says const update user query. Let's say we want to update Jacob, for example, right? How do we do that? We know Jacob has an age of, I believe, 25. Let's say he turned 26 today and want to update his age to 26, so that's not 25. We can just say update. In this case, what is the table we want to update? We want to perform the update operation on is the app users table. And then what do we want to update? We want to set age equal to, in this case, 26. And where do we want to set age as 26? Where the name is equal to, of course, Jacob. So this is the query. And then we're going to do the same jazz. You're going to let me just copy and paste this at this point. But no, I'm going to write this clearly. I don't want to just keep copying and pasting stuff. We're going to say connection to query is equal to update user query. And of course, it's going to be the error result. And I'm going to just say, if there's an error, throw error. Then we want to console log the results and say results. Of course. Now let's save this and let's try to run this and see what we get. Node server. Of course, we get affected rows is 1, which means that an update operation indeed happened. And how do we verify that? Let's uncomment the previous line, which is the reading Jacob item here. So let's just uncomment the read specific item and just check up on how Jacob is doing it, whether he's still 25 or 26 now, which we hope he is. So go here and just do Jacob and try to find the specific user here, Jacob, and just run the code. You see that Jacob is now, of course, 26. So we can now successfully update users. Awesome. We're getting somewhere now, yeah? So the final thing we want to do here is we want to try to delete a record from the database. And how do we do that? Which is the D part of the CRUD operation, by the way. So it's going to be delete data. How do we delete data? The same thing. We create a query. I call this delete user query from a particular table, of course. And then we say we want to delete, in this case, it's going to be delete from, in this case, what table are we deleting from? App users, where, in this case, I want to delete Jacob. Name is equal to Jacob. And then, of course, I'm going to type in the same thing, connection, to execute the query by saying connection.query and delete user query and error result as the callback function in the second argument. Then we want to just say, if there's an error, throw error. I also want to console.log the result and say results of delete operation. Awesome. So let's run this and see how it's looking and say node server. And as you can see, the affected rows are 1, which tells me that the Jacob row has indeed been deleted. How do we verify that? Of course, I can just go back to the previous query here and I can just go to the select specific item query to look for Jacob. And of course, when I do this, we'll probably see that he is nowhere to be found, no results. And to further prove this point that he's actually gone, which I'm sure you guys already know he's gone, I just try to read all of the users in the database, in the app users table of the database. And I can see that the only user here is Clem Brighting. Awesome. So that has been the SQL integration with Node.js. We went through the CRUD operations. We saw how all that works in both a NoSQL database and an SQL database. Of course, this is not an exhaustive SQL course, far from it, but it just gives you the foundation of actually working with SQL. And in our future projects, we'll probably not be touching a lot of SQL just because I believe that NoSQL is much more, in my opinion, tightly bound with the Node.js architecture. So that is why I will indeed be, when we build our future projects in this course, we would go with the NoSQL approach of doing things. But of course, having an idea of this is also really, really important because indeed we may do some projects with this. It is extremely, really important. That being said, this is the end of the video. The next video will be, of course, us talking about template engines and creating views with Node.js in a dynamic and scalable way, which will lead us to, talking about authentication as well as other very interesting topics. So stay tuned and please hit subscribe and like the video and comment. That stuff really helps. Thanks, guys.